The purpose of this video is to explain the quality of service feature on the ValuePoint BA-4000 broadband aggregator. And also we'll cover some other strategies you can use for controlling file sharing. As a general overview, quality of service is a technology that can be used on a gateway to basically take incoming traffic streams and assign them to different size pools of upload and download capacity based on a number of possible factors: incoming IP address, destination IP address. It basically allows you to create different classes of users or devices or application types and then assign them, either give them more data or less data based on how you want to control your system. The application that we'll be covering is mostly on a public network, being able to give higher priority to things like email and web traffic, and then lower priority to file sharing, video games, or other kinds of applications that may impact people's ability to browse the web, especially if there's a lot of users on a single network. So our assumption is you have the basic configuration of your BA-4000. You can see we've got the quality of service tab basically has submenus for each of the WAN ports on the device, along with the LAN port. So for each of your connected WAN ports, you'll need to set up the quality of service individually. And the biggest distinction between the ports is the WAN port quality of service controls the upload bandwidth. So basically it controls the bandwidth from your site out to the cloud or to the internet. The LAN port, in contrast, controls the download bandwidth. So it controls the data that comes from the internet to your site when people are viewing web pages or downloading files. But each one of these needs to be configured to enforce your quality of service rules. And in theory, you could have totally different quality of service rules for each one of these interfaces. You may have an application that requires that. But more typically, you'll want more or less the same rules on each interface. So let's take a look at a WAN interface first. So this is what it will look like by default. The first thing you need to do is enable the quality of service and then save it. This basically will turn on the quality of service for this port. And at that point, you can see some rules that are in here already. We can remove these existing rules, and we'll make some new rules. So once you've enabled the port, then you need to set the speed. And remember, this is the upload speed, and this is a DSL connection. The upload speed is about 1 megabit on this particular connection, and that will tell the 4000 how much traffic is available to be distributed between these pools. When you configure quality of service, the first thing you do is you define the pools, and those are called groups. There's a default group here, which at the moment is relatively low priority. To start with, this pool would be set to 100% because by default you want all the traffic to be available. And then the next thing you define is, for a particular pool, you add a rule that classifies incoming or outgoing traffic and assigns it to one of these pools of data. So if there's traffic that you want to have high priority, you classify it into a high priority pool based on the incoming IP address or the destination IP address. You can also do it based on a port number. Or even on MAC address. So you have a lot of flexibility here in terms of determining what traffic goes into which pool. And pretty much that's all there is to it. You just define the classes that you want to create the pools. You define the rules that assign traffic to the pools. And then the 4000 enforces all those settings automatically as soon as it's configured. Now, in deployment, of course, it can become quite complex because you may create dozens or hundreds of rules for different kinds of traffic, different users, different ports. So quality of service is a whole area of expertise. So the level that you want to delve into it will be up to you. But let's take an example of setting up kind of a simple quality of service rule. So we'll do this for the LAN. Well, let's stick with the WAN port since that's enabled already. So say we're concerned about eDonkey traffic on our network, and there's a particular group of servers that we don't like. So in order to limit the amount of traffic that can get sent to these servers, we're going to create some quality of service rules. So let's create what's basically a punitive data pool. So we're going to give this data pool a minimum rate of 0, meaning that if the network is totally busy with legitimate traffic, there won't be any traffic sent to this site. If the network is not so busy, let's say up to 20% of the available bandwidth can go to these sites. And then we'll leave it at a priority of 1, which is low priority. The higher the priority field, the more priority this pool will get if the total available bandwidth is oversubscribed. Say you have 4 pools that are all can take up to 50%. Which of those pools will get more of that available amount? It's determined by the priority. So I guess you have to set it to 10% minimum. So we'll set that to 10%. Then we also need to enable it. There we go. So now we have this punitive pool, which is class 1, and now we can assign some traffic to it. So, and we'll call this our eDonkey rule. Our group we want to assign it to is class 1. That's what we just defined above. It's not based on MAC address, but it's based on, say we know that there are some eDonkey servers that are sort of clustered around this 216.31.1 subnet. Now the notation you use here is a CIDR notation. You see I use the slash here with the bit mask. If you're more familiar with subnet masks that are more like 255, 255, 2550, you can use a calculator to give you this bit mask notation, and basically just do a Google search and look for a subnet calculator. This online IP subnet calculator is fine. You'll see some other ones you can use. Go to the CIDR notation, and in our case we wanted to use 203, 206, 13, 31.1, and say we think there's about 6 of these units. So we set the bit mask, and this tells us, so this covers 31.0 through 31.7, and then here's that notation that we were just looking at. So say we want to block 31.1 through 31.6. If we enter this rule, that'll block it on our 4000 unit. So we'll go back to our quality of service rules for port 3. I guess we didn't save our eDonkey rule. And this was the destination IP address we just calculated from that subnet calculator. The source IP, you can leave this blank, which will translate to any. Also, the notation for any is 000/0. So either one of those is fine. We're not concerned about the packet length. Now, there might be some kind of legitimate traffic going to this IP address. So let's limit it by port. And I know that the default port range for eDonkey, I think, is 4242. So let's block incoming and outgoing traffic that goes to that port. And basically, so that's all we need to do. So click on Add. Now we have a rule called eDonkey. So any traffic from our network that has a destination IP of 206.13.31.0, and it's going to 4242, it's going to get assigned to this more punitive traffic pool. Higher priority or traffic that doesn't fall into that category will default down to this default pool, which basically is an open pool at this point. And so basically that's all there is to it. Once you take a look at the rules, you can see you can select, there's a lot of places you can select protocols, you can do it based on MAC address. So if you're interested in file sharing, or you have a lot of rules that you want to add, or you want to have very specific controls over certain, video game consoles, all those things can be researched online, and there you'll find lots of suggestions for additional quality of service rules you can set up. Now, a lot of this quality of service stuff is pretty technical, so we've created a simpler solution for the quality of service. So let's disable this again, and we'll save it. That'll kind of clear out what we've got in here. And then we'll re-enable it. And once support is enabled, we've created a set of default rules that you can use that will cover 80 or 90% of file sharing protocols, including older protocols like eDonkey, as well as newer, BitTorrent protocols, as well as miscellaneous traffic that you may or may not know what it is. Basically, what it'll do is it'll divide the network into well-known traffic types like VPN traffic, emails, web traffic, FTP. All the kind of standard traffic, and then it'll have a lower priority pool for essentially unknown traffic, which could be file sharing, could be games, special applications, or just random traffic that's hard to qualify. And the way you can set those default rules is just by clicking on this Set File Sharing Rules. And it gives you a warning that it's going to delete all the rules that are in there, so that's fine. And then when we go back to the port, we'll need to enable it again. And reset it. So we'll save that. And now when we go down and look at the rules, we can see that they're pre-configured. So now we have this high priority pool that our known good traffic is going to go in. It's got the highest priority level. It always gets at least 70% of the traffic. And then we have a lower priority rule that basically is confined to 30% of the traffic. And then we have a couple rules down below to assign traffic to those two pools. And you could modify these rules, add additional rules, but in our testing, this covers 80 or 90% of the file sharing traffic. And what it'll do is basically just put all those people who are file sharing in a group together, and as a group, they can never use more than 30% of the traffic on the network. And this is a pretty good solution for controlling the impact of file sharing on your network. Now, if you want a more extreme response to something like eDonkey, you do have the option of absolutely blocking that traffic, not just lowering its priority. And that's entered under the firewall, under the port filtering rules. So if you want to enter a port filter rule to actually block all that traffic that we just talked about, you go into firewall port filtering, make sure it's enabled, make sure the default policy is accepted, because you're only making rules to exclude traffic you don't want. If you wanted to create a more comprehensive system where only, you had rules that allowed the traffic specifically, you could set this to deny. But just remember that that's going to drop all traffic that you don't have a specific rule to match. And you can see here, this is the configuration here is similar to the quality of service. You can name it, enter the source IP and destination if you want. Again, you'll need to use that CIDR format. And select the protocol that you want it to cover. You can enter ports here, and there's a lot of options for ports you can specify, or you can specify a port range, and then give the action you want. So if you set this to dropped, then you would want to set this to accept, and vice versa. And you may also, if you have both drop rules and accept rules, together you can control exactly what kind of traffic is on your network. And you can see here I've already created a rule for those 206.13.31 machines that we talked about, and basically we're just going to drop any traffic to or from those ports that we suspected of being eDonkey ports. So the question of whether to use quality of service to limit bandwidth for file sharing and other protocols, or whether to block it entirely, really comes down to a question of philosophy. Though, in our opinion, it's better to just try to limit the impact on the network. And the reasons for that are basically two. In the first case, it's much easier to define widespread control rules that will basically be effective against all the file sharing protocols, while still allowing legitimate traffic through, though some legitimate traffic that gets caught up in those rules may be slowed down. The problem with actually blocking the traffic entirely is that if you make a mistake or you have traffic that is legitimate traffic, it's also going to be entirely blocked. And in something like a public network or an ISP network, if you have users whose legitimate traffic is being caught up in the blocking rules, they're going to be upset that they can't connect at all. So in general, our recommendation is not to try to chase after every file sharing protocol and try to block every port. It's better just to try to minimize the impact on your overall network. But again, that's up to you, and certainly a combination of the two is also possible. If you have some particularly problematic ports or destinations that you see on your network, you can certainly block them specifically, like we did here, while maintaining an overall control system to minimize the amount of bandwidth that's available to those protocols. So that basically covers the quality of service on the 4000. Just quickly, if you're concerned about file sharing and you have a value point controller 3560 in addition to your 4000 aggregator, there are also things you can configure on the 3560 that will basically work hand in hand and give you a more comprehensive solution. So here's an example of a 3560. So the settings you want to look at are the global bandwidth limit, or possibly a per user limit, but the global bandwidth limit, like the quality of service, applies to everyone equally. And so a global bandwidth limit means that no one user on the system or no one machine on the system can use more than this amount of data per second. And this can be effective because you may have file sharers who are more sophisticated and you're not able to detect their traffic at all. Or you may have if you have 100 users on the system and 50 of them are trying to watch a Netflix movie simultaneously, they're just going to start, they're just going to throttle the whole network and no one will be able to get anything. So the rule of thumb that we use for bandwidth is that you should take half your peak number of users and then divide that into your available bandwidth, both for upload and download. So in our system here, we've got about, on that aggregator, there's about 10 megabits of total throughput. So if our, if we thought that our peak usage would be about 100 users, we would just divide half that, those 50 users, into 10 megabits. So those users would get about 256K each. And then the upload was about 1 megabit. So those users would get about 64K. And once you implement the bandwidth limit for all the users, you could adjust it up or down depending on how the system is functioning. Dividing by 2 is kind of a conservative limit. If you divide by 3 or 4, that'll give you a little bit more aggressive limit and people have more available bandwidth. For sites where you've got some kind of an on-site staff or an on-site manager, sometimes we hear at a hotel the general manager doesn't want to be affected by the bandwidth limit. There is the ability to create individual users and allow their setting to override the global limit. So this is really one of the most important things to set on the 3560. Otherwise, if we had 100 users on our 10 megabit system and we have no bandwidth limit, even one of those users could start downloading, some giant amount of data and use up the whole circuit and leave nothing for the other 99, or leave everyone fighting over it. So it is important, to have a realistic idea of what your user base is, as well as how much bandwidth is available. Particularly make sure you know what your upload capability is, as well as your download capability. The last area you can configure on the 3560 to help with file sharing is you can limit the number of simultaneous sessions. So every time somebody with something like BitTorrent connects to a user with a little piece of a file that they want to share, that takes up a TCP session. So those file sharers will often use 100, 200, 500, even 1,000 sessions. So if you set the maximum session count to be much lower than that, you'll have a big impact on your file sharing. While typical users sending emails and browsing web pages won't typically need more than 30 to 50 sessions. So if you set this number to 50, that's a fairly conservative number. Now that being said, we have seen customer laptops that have tons of applications and toolbars and live Twitter feeds and lots of other things that may consume a lot of sessions. So for some legitimate users, 50 may not be enough. So certainly, you can set this to 100, and that should be enough for pretty much anyone. On the downside, 100 open sessions for people doing file sharing, is a fair number of open sessions. Again, you need to kind of customize this to your site. So this pretty much covers the configuration of quality of service on your BA-4000 aggregator, as well as some of the things you can configure on your 3560 to also help with maintaining the quality of service on the 3560, as well as trying to slow down some of that file sharing traffic. So thanks very much for viewing our video. Please give us any feedback or send us any additional questions to support@valuepointnet.com. Thank you.